Okay, so today's lesson is Chapter 6, Lesson 3. It is about additional data and outliers. And today's lesson is mostly going to piggyback off of the things you learned in the last lesson. It's going to be mostly about finding mean, median, mode, except for we're going to do a couple of different things than we did yesterday. We're going to consider a couple of extra things. But we are mostly going to talk about mean, median, and mode still, with just a couple things added on. So, if you need help on mean, median, or mode still, or range, then why don't you go back and look on my videos, and there's a couple Khan Academy videos in Chapter 6 that you can review to if you can't remember how to do mean, median, or mode. So if at any point you need to do that, just open up another window and watch those videos and then come back to this video, because I'm not going to spend a ton of time explaining how to do mean, median, and mode. So, on to the lesson. What we're going to deal with today is information or data sets that have something a little bit off, and we're going to consider data sets with and without some information. And the first thing I'm going to talk to you about is I'm going to use Lena's as an example. Let's say I went to Lena's 5 times and I spent these amounts of money. I went 5 times, and one time I spent $10, another time I spent $10, 2 times I spent $12, and one time I spent $8. And then I went a 6th time and I brought my whole family and I spent $50. So what we're going to do is we're going to find, if I wanted to know how much money I should bring to Lena's the next time, I need to find average or mean, and that'll give me a good idea of how much money I should bring the next time. So I'm going to find the mean or average in order to figure out how much money I'm going to spend. So I'm going to take all 6 of those numbers, and I'm going to do like we learned yesterday for the mean. I'm going to add them all up. So I'm going to do 10 plus 10 plus 12 plus 12 plus 8 plus 50. And I'm going to end up getting 102. Then I have 102. And there were 1, 2, 3, 4, 5, 6 numbers, so I'm going to divide by 6. 6 goes into 10 one time, which is 6, which leaves me 4, drop the 2, 6 goes into 42 7 times. So, if I use that data set, then I would say that I should bring $17 to Lena's. But, let's take another look at that data set. I said that on average I spend $17, but look at most of these numbers. $10, that's a lot less than 17. So is 12, and $8 is much less than 17. And then this 50 is way more than 17. So is 17 really, does that really indicate how much money I should bring to Lena's? I would say no. So what I'm going to do is, since $50, that's so abnormal, it's called an outlier. It's a piece of data that doesn't really fit with the rest. So an outlier is a piece of data that's far different from the rest. So this 50 is an outlier here. Most of the time I don't spend $50 when I go to Lena's. Most of the time I spend far less. So this time what I'm going to do is I'm going to look at mean. Another word for mean is average, and I'm going to look at it without that 50. So this time I'm going to erase that 50. I'm going to forget about it, and I'm going to find the mean again. So I'm going to erase all these numbers over here, and I'm going to try it again. 10 plus 10 plus 12 plus 12 plus 8. And that's going to be 52. And then it's 52, and there are 1, 2, 3, 4, only 5 numbers this time, so I'm going to divide it by 5. 5 goes into 5 once, which is 5. 0, drop a 2. It does not go into 2. Now here's where my decimal will be, so I'm going to carry it up. And then I'm going to drop this 0, and it's 20. 5 goes into 24 times. So in this case, I would get 10.4, which when it comes to money means $10.40. Now, let's take a look at the other times I've gone to Lena's. $10, $10, $12, $12, $8. Does $10.40 seem a lot more reasonable? It does. So if you were going to ask me what's the average amount of money I spend when I go to Lena's, which number is a better representation? $10.40 or $17? I would say that $10.40 is a better representation, because this 50 really bumped up this number over here, this $17. So sometimes when you see a data set with a number that is way off like this 50, you need to consider it with and without, and then you need to just figure out which one makes more sense. So we're going to practice another problem together. Let's go to baseball, since the Royals have just made the World Series. But let's consider a baseball hitter. So in baseball, you see a lot of averages in baseball, and you see a lot of data numbers. And let's take a look at a couple players. Well, let's take a look at a different player. He's not in the Royals. A player who's retired now. Let's take a look at Barry Bonds, who some people consider to be one of the best hitters ever. In 1999, he hit 34 home runs. In 2000, he hit 49. In 2001, he set the record by hitting 73 home runs. In 2002, he hit 46, and in 2003, he hit 45. Let's figure out, first let's take a look at those numbers. 34, 49, 46, 45, and 73. If you had to pick an outlier there, which one would you pick? You'd probably pick 73, because it's far different from the other numbers. 34 is only 11 away from 45. But 73 is 24 home runs bigger than 49. So 73 would be our outlier. So something that it's going to ask you to do in homework and things like that is it's going to say, find the mean with 2001 and without. And it might say something like, which one is a better representation? So let's put our numbers up here in the top left. Let's see, it's 34, 49, 73, 46, and 45. So first, let's find his mean with 2005. So let's try it with. So we're going to do 34 plus 49 plus 46 plus 45 plus 73. So if we add, we're going to get, oh, by the way, I want you to pause and solve with 2001. Pause and solve. Okay, so we're going to add them all together. We're going to get 27, and we're going to get 24. So in those 5 years, he hit 247 home runs. And in order to find out our mean or average, we're going to divide it by how many numbers, and that's 1, 2, 3, 4, 5 years. So we're going to divide it by 5. 5 goes into 24 4 times, which is 20. Drop the 4, 47. 5 goes into 47 9 times, which is 45. So we're going to bring our decimal up. Then we get a 2, we're going to drop a 0, 20, so 49.4. So his mean home runs was 49.4 in those 5 years, including 2001. So now let's find it without. So all we're going to do is the same thing, except for we're going to take out that 73. So then we're going to add them together, and we get 74, 174 home runs. And then we're going to divide that by 4. 4 goes into 17 4 times, which is 16. And it goes into 14 3 times, which is 12. He gives us a 2, drop a 0, 43.5 home runs. So, our answers with 2001, his average was 49.4. Without, it's 43.5. So let's look at those numbers. 45, 46, 34, 49, and 73. Which one is a better indicator? Well, we have 45, 46, 34, 49. They're all, this 43.5 kind of falls in between all of them, doesn't it? It's just below those two numbers and a little bit above that number and a little bit lower than that one, and it's far lower than this one. But this one, you see, is far more, 73 home runs is far away from what he ever did since. So let's take a look at 49. 49 is actually higher than 4 of the numbers. So if you're talking about if your average is higher than most years, which one do you think would actually be a better representation? I would argue that 43.5 home runs would be. So those are the kind of things it's going to ask you on your homework. So think about that when you're doing these problems. Think about, is there an outlier in this? And if there is an outlier, is your mean, is it better? Oops, I was trying to circle that. Is your mean, is it more accurate with or without? Usually it's more accurate without, but sometimes you might want to consider it. So that's all there is for today. We'll see you tomorrow.